Hi, everyone. We're going to take a look at the Algebra 3, Chapter 1, or actually Chapter P. P stands for prerequisites, practice test. We're just going to do problems 1 through 6, which is the front of that sheet, and hopefully this makes sense to you. If I move too fast, just rewatch whatever I moved too fast through. All right, without any further ado, here we go. Number 1 is just trying to see if you understand the relationship between interval notation and inequalities and being able to graph these on a number line. So for this first one, we got to remember that a bracket means that it includes that value, whereas a parenthesis means it does not include that value. So what this is saying is that x is somewhere in between. Let me write that a little bit smaller. There we go. X is in between -8 and 3, but it could include -8. And so in terms of writing it in inequalities, that's how I'd write it. On a number line, real simple, you just pick those two values and bring them down, -8, 3. I like to usually put 0 to kind of signify where that's at. And then because it includes -8, I'm going to fill in the dot there. It does not include 3, so I don't fill in the dot there. And I just graph the in-between. So that would be how to graph that interval and express it in an inequality. For this next one, this is where a lot of people go wrong. A lot of people have tried to do this. Let's see. Okay, and that is wrong because you're never going to say that x is less than negative or greater than negative infinity, or you don't read that negative infinity is less than x. So really what you do is you've got to take this part right here just out. That is just wrong. So you should never have that on your paper. The correct answer is just this. If we say x is less than 3, well, then our assumption is that it goes forever all the way to negative infinity. And so then to graph this on a number line is very easy. Again, it's good to have 0 as a reference point. I'm going to put 3 right here. It says less than, not less than or equal to. So I put an open circle right there and then kind of highlight it this direction and put an arrow. So it shows that it goes forever that way, all the way to negative infinity. All right. Now, number 2 is the same problems, but just vice versa. We got to go the other way this time. So now this one says x is less than -2. And so therefore, we want all of the x values less than -2. So very similar to that last problem we looked at, it should look like this. We go negative infinity all the way up to -2. And if we graph that, it'll look almost identical to that last problem we did, except we're on this side of the 0 this time. And we're going this way. Okay. All right, for this other one, it says x is in between -5 and 9, and it can include -5. Well, that means that we're going to put in interval notation. It's going to look like this. Again, because this bracket means that's the same thing as or equal to, and the parenthesis is the same thing as it's just got to be less than or greater than that. When we want to put it on a number line, that's real simple. Again, it's good to put 0 as a reference. I'm going to put -5 about here, 9 up here. We include -5, but we don't include 9. So and then I shade everything in between. All right, and that's what you should have. Okay, number 3, this is the best way that I could come up with to write this so we could kind of keep referencing back to the sets A, B, C, and D. So I'm going to try to write the sets beneath those right there on the screen. But first thing I'm going to do is I want to illustrate any of these that are a interval, a range of values. See, these first 2, A and B, they just include what's called these discrete values. Okay, it doesn't include any of the numbers in between -2 and 1. It just includes -2 and -1 and 0, 1, 2, and 3. Same thing with B. B includes 1/2, 1, and 5, but it doesn't include any of the values in between there. And that's where C and D are very different. C includes all the values in between 1 and 4. D includes all the values in between -1 and 3, and it even includes 3. So what I want to do is I just want to kind of put a number line for these two for reference sake. So I kind of have a visual understanding exactly what they are. So I'm going to try to line them up and put 0 in about the same spot. This one says it goes from 1 to 4. And it does not include either one of those. And the other one goes from -1 to 3, and it includes the 3, does not include the -1. Okay, it looks like that. All right. Now, let's go on down the list. The first couple of these are so easy, okay? The union of A and B. Well, union, we got to remember what union is. Union is all. So when we see this, that's all of both. And when we see this, that's intersection. That's only the overlap, only the ones that they both have. So A here, part A is the union of sets A and B. So it's all of both of them. So we go, okay, we just have to include everything. So that's going to be -2, -1, 0, 1/2. That B brings that one in. 1 was already in both of them. 2, 3, and then B brings in 5. Okay, so that's the answer to this part right here. All right, now I'm going to slide that down a little bit so it's kind of out of the way. All right, now the second part, the intersection of A and B. Now this is really easy because the intersection is only the overlap, only where they overlap. And when I look at those, A does not have 1/2 and it doesn't have 5. It only has 1. So the intersection is just 1, and that's it. All right, let's look at part C. Now we're looking for the union of C and D. Now remember, union is all of both. Now I like this one. When you're doing union, especially with these kind of ranges of values, really you're just pushing these two things together. I mean, I try to imagine almost a third number line. I'll draw one right here. Try to imagine a third number line where I just put all of it. Say, okay, well, it goes here, 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 and fill this in. And then it goes from here to here, and then from here to here. Now, here's the thing that happens. This value right here, even though it's not included on the top graph, it is included on the bottom graph. So it gets included. So the union, when I push all those together, is everything from all the way back here at -1 all the way up to 4. It just doesn't include -1 or 4. Okay, so I could write that like this, -1 to 4, and use parentheses. I could say that x is in between 4 and -1. Either way, you're completely okay. Or if you wanted to use these fancy curly Q brackets, then you'd have to write it, set of x such that, again, -1, x, 4, you could write it like that. All three of those are acceptable for this one right here. Okay? Now, the intersection, that's a little bit, I think that's a little bit easier because that's, again, it's only where they overlap. And so I'm going to take this apart a little bit and go, where do they overlap? They only overlap in this little middle section right here, okay? And because the top graph does not include the number 1, then the overlap doesn't include the number 1. And the bottom graph only goes up until 3. So we can't go any higher than that. And so it would just be from 1 to 3, including 3, but not 1. And also, if you did that with inequalities, it would look like this. If 1 is less than x, which is less than or equal to 3. Or if you wanted to write that as a set, again, I'm going to move this other one kind of out of the way, bring it down a little bit. If you're going to write that as a set, you'd say, well, it's the set of x such that 1 is less than x, which is less than or equal to 3. Any one of those three ways would be completely acceptable. All right? Okay, then, so A and B and C and D, those kind of made sense. It's these last two that has caused so much problems for so many people. Because now we're mixing the two. We're mixing these sets like A and B that have these discrete values with sets like C and D that has this whole range of values, all the decimals and fractions in between, okay? So this first one says, where's the overlap, the intersection of A and C? Okay, so where's the intersection of A and C? Now, what I can see is that C does not include 1, but A does. But 2 and 3 would fit in between 1 and 4. Only 2 and 3, not the numbers between 2 and 3, none of that. And so the intersection would just be the numbers 2 and 3. That's it. Okay, notice that those are not brackets or not parentheses, so it's not this range of values. It's only the two numbers, the discrete numbers, 2 and 3. The same thing happens when we're doing the intersection of B and D. So you're going to go, which of these values out of B here, which of these values fall within this range of values of D? Well, 1/2 is in there, and 1 is in there, but 5 is not in there. And so it's just the two discrete values, 1/2 and 1. And that's it. And everyone wants to overcomplicate that and say, well, it's got to include all these other values. But that's not the case because it's only the overlap. And with those first two, A and B, they were just these discrete values. Okay, moving on because we took too much time on that one. All right, number 4. This says 64 to the negative 1/3. First thing you should be thinking about is anytime you have a negative exponent, it always moves this. So this is the same thing as 1 over 64 to the 1/3, which is then the same thing as 1 over the third root of 64. And the third root of 64 is 4. So this is just 1 over 4 or 1/4. Okay, this next one, it says square root of 288 divided by the square root of 2. Now, I don't know what the square root of 288 is, and I don't know what the square root of 2 is, but I know that because they're the same power root, those are both square roots, I can make it under one fraction. I can say the square root of 288 divided by 2, which is the same thing as the square root of 144, and the square root of 144 is 12. Now, for both of these problems, this is the level of work that I will require for you to get all possible points. You should be able to show me how you're getting there and not just come to just this answer and be like, hey, check it out, I got it. Like you have to have the in-between steps as well. All right, for part C. This one right here, a couple people freaked out because they saw this, they saw the negative sign. But it's okay to have a negative under an odd numbered root radical. You can't have it under a square root or fourth root, but under a third root, that's completely fine. Okay, so this, all we're doing is we're just looking for what number times itself 3 times gives me 216. And it would be negative 6. Let's see here. Negative 6 times negative 6 times negative 6. Okay. And so that would then mean I've got 1, 2, 3 of them. So it can come out as a negative 6. All right. Okay. Lastly, part D is probably the hardest problem of the set of that group of number 4, but it's just because it throws us back into elementary school with fractions. Okay, this first one this would be the same thing as 1 over 3 to the third power minus 1 over 4 squared. That simplifies down. You got to remember 3 to the third power is not 9. It's 3 times 3 times 3, which is 27, minus 1 over the fourth squared is 1 over 16. So all you're doing is you just have to subtract the two fractions, 1/27 minus 1/16. Now, 1/27 does not have a nice decimal. 1/16 does. So I have to find a common denominator. And so the common denominator between these two is 27 times 16. Golly, what is that? That's 270, 390, 432. Okay, so this is 432. Okay, to get that on the bottom, I had to multiply the top and bottom by 16. And for this one, I have to multiply the top and bottom by 27. 432. Yeah. And so then you just say 16 minus 27, which is negative 11, 432. Or negative 11, 430 seconds is how it would be properly pronounced. All right. The next one, this is simple. It says write them as rational exponents. Remember, the word rational means fractions. And so I literally just have to say x to the 9/3, y to the 8/3, z to the 12/3. And then my job would be to simplify if anything does. 9 over 3 is 3. 8/3 does not simplify. 12/3 is 4. And there you have it. The next problem is exactly the same, okay? You say, well, this is the same thing as 32 to the 1/5, x to the 12/5, y to the 5/5, and z to the 10/5. Now, the fifth root of 32 is 2, because 2 times 2 times 2 times 2 times 2. 2 times 2 is 8, times 2 more is, 2 times 2 is 4. I could tell I did something wrong. 2 times 2 is 4, times 2 more is 8, times 2 more is 16, times 2 more is 32. So that simplifies down to a 2. The x to the 12/5 doesn't change. Y to the 5/5 is just y to the 1 or just y. And z to the 10/5 is z squared. And so that's what it should equal. This was just here to kind of help us see that we don't have to have that. I'm going to get rid of that. Okay. All right, and this one, part C, we actually did this one in class, so hopefully everybody remembers, but we said this was the same thing as 8 times 4 times the fourth root of x times the third root of x. Because multiplication is commutative, you can multiply in any order. So 8 times 4 is 32, and then I look at these and say, man, this to me is easier to look at like this and write them as rational exponents. I know that when I multiply two exponents like x squared times x to the 7th, I get x to the 9th because I basically just add the exponents. And so that's what I have to do here. So I have to ask myself, well, what is 1/4 plus 1/3? Well, the common denominator is 12. So the first fraction, I have to multiply the top and bottom by 3. Second fraction, I have to multiply the top and bottom by 4. And I get 7/12. So that's what this is going to be. 32x to the 7/12 power. All right, part D. This one is a little bit more complicated. You know, I look at this and say, well, let's make this xy to the 1/4 power over, let's see here. Now, I know the square root of 81, so I'm going to go ahead and pull that out. 9 xy to the 1/2 power. Now, when I have a power over a power, like if I had x to the 7th over x squared, I subtract that. That becomes x to the 7 minus 2, which is x to the 5th. Now, that's pretty easy for us to recognize, but if it's flipped, sometimes we struggle with that. It's really x to the 2 minus 7, which is x to the negative 5, which is 1 over x to the 5th. All right? Now, you can see on the top we have 1/4, on the bottom we have 1/2. 1/4 is smaller than 1/2, so it really kind of falls under this situation, which means we're going to be left with xy's in the denominator. Okay? That's one thing I know. And so another way of looking at it, though, is I say, well, what is 1/4 minus 1/2? And the answer is negative 1/4. And so this would be equal to xy to the negative 1/4 over 9. But we don't want to leave it like that because when we have a negative exponent, we want to deal with that. And so we shift that to the bottom, and this becomes 1 over 9 xy to the 1/4. And that's our final answer. All right. Number 6, last problem that we're going to do today. The first one is, hey, just factor. What do these two things have in common? Well, they both have a 6 inside them. They both have at least one x inside them, and they both have y squared inside them. And if you look, that's all of this second term. So when I pull a 6 out of the first term, I'm left with a 2. When I pull an x out, I'm left with an x. And when I pull a y squared out, I'm left with a y. But when I pull 6xy squared out of the second one, the only thing I'm left with is a 1. That 1 is kind of like a placeholder because you need to be able to multiply back out this one times this one and this one times this one and get what you started with. If you can't, then you factored wrong. So that 1 has to be there as, like I said, kind of a placeholder. All right. For this next one, this is a trinomial, basic trinomial. We're looking for factors of negative 18 that add up to be negative 7. What are the two factors of negative 18 that add up to be negative 7? Well, that would be negative 9 and 2. When I multiply them, I get negative 18. When I add them, I get negative 7. So this is just x minus 9 times x plus 2. Next one. Now, this is the same kind of problem. But the only difference is for these, you always had to multiply the first and last terms, which gets me negative 24. And now that's the number that I need two numbers that multiply, but then also add to get negative 10. And let's see here. Negative 10, I'm going to go that is negative 12 and positive 2. A lot of people are going to jump and say it's 6 and 4, except you would have to have one of them has to be positive, one of them has to be negative for you to get a negative 24. So it can't be 6 and 4 because they'd have to both be negative for us to get negative 10. I hope that that makes sense. When I add negative 12 plus 2, I do get negative 10. And when I multiply negative 12 and 2, I get negative 24. But if I do that same thing with, if I say negative 4 plus a negative 6, I get negative 10. But when I multiply negative 4 times negative 6, I get positive 24. So that doesn't work. All right, hopefully that makes some sense. All right, so I break that middle one into those two values, 3x squared minus 12x plus 2x minus 8. The first one, I'm going to go, all right, let's take, what can I take out of those? I can take a 3x out, which leaves me with x minus 4. The second one, I can take a 2 out, which leaves me with x minus 4. And then I factor that 3x plus 2 times x minus 4. Yay. All right, this one is the exact same thing. It's just the first step's already been done for you. You factor by grouping. You factor these two and you factor these two. Out of the first two, I can take an 8x squared, which leaves me with x minus 2. That's supposed to be an x. And out of the second one, I can take out a 9, which leaves me with x minus 2. And then I go, okay, so this is 8x squared plus 9 times x minus 2. Pretty simple. I'm not too worried about this last one. I will show you real quick how I did it earlier. I said we're going to use some substitution. So I'm assigning some substitutions saying, hey, let's let u equal x minus 1. And then rewrite this. I would get u squared plus 2 times u plus 1. Now that's super easy to factor. Everyone should know that that's just u plus 1 times u plus 1. Now that we've factored it, we resubstitute that back in place, which gives us x minus 1. Okay, that's the u. Plus 1 times x minus 1, that's the u, plus 1. Well, minus 1 plus 1 those cancel out. So I'm left with x times x, which gives me x squared. So it's amazing that this thing right here factors down to something so simple. All right, that's the end of the front of this page of this practice test. Hopefully you're ready.